So the original scope of this project was to use Simulink to develop a model to calculate the time constant for many capacitive sensors that are connected to an Arduino, which is connected to the computer and then Simulink. And there are only a few different functions that Simulink has that work with the Arduino directly. And so I actually developed this model here, and it's a pretty simple model that does exactly or similar to what the library in the Arduino does for capacitive sensing. And so the Arduino capacitive sensing library runs continuously, and it toggles the input high, and then while it's waiting for the digital, or it toggles the output high, and while it's waiting for the digital input to correspond to that high, it counts up for each iteration through the loop. And so it's not actually using the internal timers in the Arduino. And so that's what I'm actually doing here. And then this is just showing the complication of using Simulink to grab the maximum count value once this flips and switches to a low state and starts a new calculation of the time constant. It's a lot easier to do programmatically, I found, than to do in Simulink. Maybe there's a really easy way to do it. There probably is. But this is just how I was saving that maximum value. An issue I found, however, is that because this runs really quickly on the Arduino, it can calculate the time constant for very small increments in time. For example, the Arduino clock speed is 16 megahertz, which, yes, it takes more than one clock cycle to go through a single loop, but the minimum sample time that I was able to achieve or input into this without experiencing any lag was 1/10,000th of a second, which is equivalent of 10 kilohertz, which is much less than 16 megahertz. And so I was able to sense the time constant for very, very large values of very large capacitances. So if I would directly touch the positive and negative leads, you could see that output. So I know this was working. It's just I could not reduce the sample time enough to get practical results. So the next thing I tried to do was port in the capacitive library from the Arduino IDE into a custom S function in Simulink, and that did not work because of errors that I couldn't figure out. So finally, I resorted to using running everything on the Arduino from the Arduino IDE, and then just serial printing like I was before the time constants, and reading in that serial data to Matlab. And now I'm doing all the post-processing of that data using Matlab. So this video here shows the results. Okay, there's actually 2 extra plots on here. I'm only reading in 2 sensors, and you can see the analog data. But I'm actually developed an algorithm, which is pretty simple, to determine whether I'm getting a actual water detection or not. So the way it does this, the Matlab reads in the points continuously and saves the last 200 points for each sensor. And then it keeps track of the minimum for the last 30 points and the mean for the last 5 points. And then if the mean minus the minimum is greater than a certain threshold, then we say that sensor is detecting. And so we make that basically a digital high. So you can see my quote-unquote digital signals, and I have them at arbitrary values just so that you can see them on the graph. I found that I tried plotting them in subplots, but apparently subplots take longer to update in real time, so I'm just plotting them all on the same plot here. But it actually is pretty accurate and repeatable. So next steps from here are to optimize the thresholds and those mean and minimum number of points that I'm keeping track of. So hopefully I can do that within Matlab as well. That's all for now. Thanks.